naman nakasala pa.
So, today's lesson will be all about finding the derivatives of a natural exponential function.
What? Derivatives? I can't even use it in real life situations.
What is the noise all about? You, Mr. Sabino. When do we use natural exponential functions in real life situations? How about you, John?
Dumamo ka na. Koko. Ikaw naman. Go.
Please give me an answer this time. Crystal, stand up, please. I think it's not applicable in real life situations.
Go.
Oh, the line. What is the answer? Natural exponential functions are useful in many areas like biology, physics, and etc. It is used in real life situations such as in radioactive decay, population growth, saving money, and many more.
But before we proceed with the lesson proper, let us first discuss the derivatives. A derivative refers to the rate of change. It can also be the rate of change of a velocity at any time or the rate of change of a function slope.
So natural exponential functions are actually exponential functions with the base of
So E is considered natural because it arises naturally in math, just as pi arises naturally in geometry. For example, we have the equation y is equal to e raised to x with the base of e, which is also equal to the equation f of x is equal to e raised to x with the base of e. Other examples are f of x is equal to e raised to 2x plus 3 and f of x is equal to e raised to x cosine of 3x. So, in finding the derivative of the natural exponential function, one important property of the natural exponential function is that it is its own derivative. So we have the equation y is equals to e raised to x. So finding for its derivative, we have y prime is equal to just copy e raised to x and then multiply it with the derivative of x, which is 1. So y prime is still e raised to x. Another example is the equation f of x is equal to e raised to 2x. So finding for its derivative, we have f prime of x is equal to just copy e raised to 2x and then multiply it with the derivative of 2x, which is 2. So 2 times e raised to 2x, we have f prime of x is equals to 2e raised to 2x. So for our second equation, we have f of x is equal to e raised to the square root of x plus 4x. We can rewrite the equation, which is f of x is equal to e raised to x raised to 1/2 plus 4x. So for its derivative, we have f prime of x equal to just copy e raised to x raised to 1/2 plus 4x multiplied with the quantity, which we find the derivative first of the first part of the binomial, which is x raised to 1/2 the derivative is 1/2 x raised to negative 1/2, and 4x, which has the derivative of 4. So the final answer, we have f prime of x is equal to e raised to x raised to 1/2 plus 4x times the quantity 1/2 x raised to negative 1/2 plus 4. So for our last equation, we have f of x is equal to e raised to 3 cosine of 7x plus 8x. So f prime of x, we have e raised to 3 cosine of 7x plus 8. We just copied it and multiply it with the derivatives of our exponents. So we copy 3 because it is a constant. We find the derivative of cosine of 7x, which is negative sine of 7x. And since this is a chain rule, we need to find the derivative of 7x raised to 7. And then 8, which is the derivative of 8x. So we have f prime of x equal to e raised to 3 cosine of 7x plus 8 times 21 minus sine of 7x plus 8. So final answer, f of x is equal to e raised to 3 cosine of 7x plus 8 times the quantity negative 21 sine of 7x plus 8. So before ending, I would like to leave you with an assignment for you to be able to practice on. So this is a 5-item assignment which would be of great help to you for you to be able to master this lesson. So that's all for today. Thank you and goodbye, class.
Thank you and goodbye, teacher.